All right, this is going to be an introduction to OpenDRT. So we can find OpenDRT at the GitHub project, and it's called OpenDisplayTransform. And there's a lot of different stuff in here. There are multiple display transforms actually, and also some look modification tools and other utilities. But if we go into the display transforms folder in OpenDRT, this is where there are a DCTL version for DaVinci Resolve and a NK node for Nuke. However, if we go to the releases page here, we can see that there's a 1.0 release. And yeah, so basically OpenDRT is a open source picture formation transform or display rendering transform or output transform or whatever you want to call it. Basically what it does is it tries to create a nice looking picture out of raw camera data. It provides a built-in set of basic look development operators and ships with a few good presets out of the box. And if we go down here, we can see a few screenshots and stuff, and then there are these files in the releases. So what we can do is we can download these files, and I will walk you through how to do a basic installation and usage in DaVinci Resolve and in Nuke. So first things first, I have these downloaded in this folder here, and we have the DCTL and the Nuke script and 2 OpenColor IO configs and the second version of the DCTL. So first we're gonna focus on DaVinci Resolve. So how do we install these DCTLs? Well, if you go into DaVinci Resolve, and I have a little test project here with some open test footage. If you press Shift 9, that's going to open the project settings, and we're going to first install the DCTLs. And this requires DaVinci Resolve Studio. So if you have the free version of DaVinci Resolve, this is not going to work. So we'll click on the Open LUT folder, and this basically opens the folder with all of the LUTs in it where you can copy and paste the DCTL files into. So I'll just copy and paste these in here, and we're going to restart Resolve. Okay, back in Resolve after restarting, and we're going to do a little bit of setup first. So if we press Shift 9 again, go to the color management, and we're going to change the timeline color space to DaVinci Wide Gamut Intermediate and output color space to Rec 709 Scene. And we'll hit save. And right now we're in the edit page. So we're going to press Shift 6 to go to the color page. And we're going to do a couple of things. So first we're going to convert this footage into the timeline color space. So I know that this is an EXR sequence loaded in, and I know it's linear and it's encoded in DaVinci Wide Gamut. So if we right click here on the clip and go to add into new group, we're going to call this DWG for DaVinci Wide Gamut, and that creates a few different things up here. So we have group pre-clip, clip, group post-clip, and timeline, and these are different stages in DaVinci's color management process. So first thing, we're going to go to group pre-clip, and we're going to add a color space transform, and we're going to set this to DaVinci Wide Gamut linear, and the output's going to be DaVinci Wide Gamut DaVinci Intermediate. So this is converting from linear to DaVinci Intermediate log. And importantly, we're going to turn tone mapping off because we do not want tone mapping when we're doing this type of conversion. Please remember to do that, or you will be shooting off your foot at the very first step. All right, step 2, we're going to go to the timeline level, and basically we're going to add a DCTL. I'll just press Shift S here to add a node, add a DCTL, and add OpenDRT 1.0.0, which should show up in your list. And we'll just set a label here and call it OpenDRT. And now we can see the UI of OpenDRT. I'll just make this a little bigger. And we can see the image is changing from the low contrast log image into a picture that looks nice. This is the picture formation transform. And so we can scrub through here and see some different images. So yeah, out of the box, OpenDRT comes with only a few different controls. The important ones you need to know about are the input gamut and input transfer function. So we could change these if we wanted to. Say you're working in a project which has a different input gamut, you can change that here. And we also support quite a few input transfer functions out of the box. DaVinci Intermediate is the default one, but we could use linear or T-log or Fuji, F-log2 or any of these. And then most importantly, there's a few different presets that we can choose from. So first, we'll talk about the display encoding preset. So by default, it's going to be set to Rec 1886, which is a quote-unquote Rec 709 display with a 2.4 power function EOTF designed for a monitor calibrated to 100 nits. We can also choose an sRGB display with a 2.2 power function EOTF, or display P3, which is targeting a Apple-style P3 gamut device. And there's also Rec 2100 PQ, which is an HDR display spec, and also HLG, and also a Dolby style PQ with P3 primaries. Those are the ones that are available out of the box. And then OpenDRT also ships with a few different presets. So there's look presets and tone scale presets. So if we select the look preset dropdown, we can see that there's default, colorful, umbra, and base. So default is a good default preset. It has some basic preferential hue distortions to make a nice looking picture and adds a little bit of contrast. Colorful is a more vibrant preset, which might be good for feature animation. Umbra is a darker, more cinematic preset, which might be interesting for like a more filmic vibe. And then base is a preset with all of the preferential look operations turned off. So this does not make a nice looking picture. The purpose here is to create a picture that might be a good starting point for in-depth look development applied upstream. And then importantly, if we select a look preset, we can also change the tone scale preset independently of the look preset. So this gives you kind of some creative flexibility, even though the out-of-the-box UI is pretty simple, or limited, we could say. So we can choose the different look presets. So default is actually using the high contrast look, so it doesn't change when we switch to that. But if we wanted a more lower contrast look as a starting point, we could choose this one. We also have the ACES 1, or something resembling the ACES 1 tone scale function, something that exactly matches the ACES 2 tone scale function, and a few other fun presets to choose from. For more information on what the look presets are and what they do, feel free to check out the release notes. And then we can also change the creative white preset adjustment. So by default, maybe let's look at this gradient here. So by default, the creative white is set to D65, which means that the output code values for a D65 display, which is all of the presets here, is going to be equal code values. So we can see this is quote unquote neutral. If we change this, we can see that as we change it down, it's getting warmer. So D50 white is making the peak luminance match D50. And then the creative white range slider here is basically an adjustment to determine how much we affect the overall range. So if creative white is 0, we're affecting less of the midtones and shadows with this creative white adjustment. And if it's 1, we're affecting the entire image intensity range. Okay. Next, let's talk about, let's find a good picture to talk about this. So next, let's talk about the, oh yeah, and then creative white, you can also use the look preset because the different look presets have different settings potentially. So if we choose Umbra, this actually has a warmer D50 white point, as we can see. And if we choose look preset, it's just going to use the look preset. Otherwise, it's going to do kind of an override. Okay, so let's switch to default, and I'll talk about the display peak luminance, HDR gray boost, and HDR purity controls. So these are designed for HDR because OpenDRT, one of its design goals is to have a very good transition from SDR to HDR. It's a transform that's designed with that use case in mind. So if we are in a SDR preset like Rec 1886, if we boost display peak luminance, it's actually going to pin the peak luminance at the display peak because otherwise it would be clipping. So what's happening here is instead of the highlights getting clipped, the mid gray point is actually being reduced. So we can see the overall image exposure is being reduced. If we are in an HDR preset like Rec 2100 PQ, obviously this is an SDR screen capture, so I'm not able to show you what this would look like in HDR, but please test on your own HDR display. If we boost HDR peak luminance, we can see that middle gray is being pinned, or not pinned exactly, but not changing that much, and the peak luminance is being boosted. So the display peak luminance, you basically set it to the peak luminance that you want. So for example, if we set this to 600, we are making a 600 nit HDR picture formation transform. So, and then HDR gray boost is basically how much to boost middle gray exposure as peak luminance is increased, and this is measured in stops per stop of adjustment above 100. So if we go from 100 to 200 nits, this is boosting by 1 stop. If we go from 200 to 400 nits, this is boosting by another stop, and so forth. So if this is set to 0.1, we're basically going to boost the middle gray by 1/10 of a stop for every stop that the display peak luminance is boosted. Effectively, this allows you to creatively control the overall image exposure in HDR. It seems that the typical setting for this is around 14 nits for middle gray, coming from 10 nits in 1000 nit peak luminance, but ultimately this is creative, so feel free to adjust as needed. By default, it roughly matches the RE camera and ACE's picture formation transforms in HDR. Cool, and then to describe HDR purity, I will go to a more colorful set of image data. This is from the HDM Stuttgart HDR test image set, which is amazing. So this is not a great way of viewing this, so I'm actually going to switch the display encoding preset back to Rec 1886. So as we boost HDR peak luminance, just pretend that our image is HDR here. And if we go up, we can see that the purity of the highlights is actually changing. And so this HDR purity, and that's because the tone scale control is being adjusted, and the tone scale affects the purity compression, which we'll get into in more detail later. But basically, if we increase display peak luminance and we change HDR purity, we can see that this is basically a control to determine how saturated you want your highlights in HDR. And I'm using the term highlights very loosely here. Please put air quotes or scare quotes around that term in your mind. So if we set HDR purity to 0, when we change the display peak luminance, the purity compression behavior as intensity increases is actually not changing at all. Chances are you don't want this because highlights look less colorful. Again, highlights in scare quotes. So chances are you probably want some increase in purity preservation as the display peak luminance is boosted. And yeah, the danger is that if you go too far, you can start to introduce gradient disruptions in pure colors. Let's see if we can find some other examples here. Yeah, so anyway, it's a creative control. Let's go back to 100 nits HDR, reset these. So there's also another variation of OpenDRT, which is called the quote-unquote stick shift version. If we switch to this, we can see that there's an absolutely overwhelming quantity of parameters here. And so basically this exposes all of the creative controls and does not have presets. So by default, it comes out of the box with the default preset. Unfortunately, the UI of DCTL is very limited, and we don't have many options for doing grouping or tabs or any other sort of nice UI features. So apologies in advance. I would probably recommend that you don't use this and design a preset in Nuke and save a preset out and as a new preset in the base version of the DCTL. But I'm providing this in case people are curious and only have access to Resolve, although there is a free version of Nuke that you can do this in. And I'll go into more depth in a later video about how to do that process. So by default, it matches OpenDRT default, and all of the controls are available here. And there's also enable, disable buttons for the different modules. So there's a few modules which I'll go over in more detail in the Nuke node. But yeah, you can turn these off and kind of see what they do. And also, if you're curious what the individual parameters do, if you hover over, there is a tooltip overlay, which is very annoying to read because it is just a very long string of text, but hopefully it's helpful. All right, so that's the usage of OpenDRT in DaVinci Resolve as a DCTL.